Alright, so getting into this next set of videos, we're going to start talking about inheritance between classes in Java. So to get started with this very first video in this set, we're going to go through a brief introduction of inheritance. In this introduction, what I want to talk a little bit about, we're first going to look at a conceptual description of what inheritance is. We'll talk a little bit about the benefits of inheritance, and we'll look at a simple example of this by implementing two classes in which we have one inheriting from the other, and then we'll wrap up by also talking a little bit about the way in which we can create UML diagrams by also including inheritance as part of our description in those diagrams. Okay, so to get started, we'll first take a look at this conceptual description. So essentially what we have right now is we have our set of classes, say like our rectangle class that we've been working with. Let's imagine that the class itself, so we have a very simplified initial description of a UML class diagram. We just want to represent the name right now, so we're going to exclude the fields and methods. We'll just show the name, and then I just want to show the relationship between this class and another class. So right now we have a rectangle, and we want to add on to this an additional class. And the purpose of this additional class is that we want to allow the rectangle to be able to essentially get whatever information is included inside of this class and be able to use it within itself. And the idea here is by including this relationship of inheritance. So to do that, I can create this here and something kind of like that. So the general idea is that we want to have a rectangle inheriting from our shape. So what exactly does that mean? Well, in the simplest case, what we could say, if we want to describe the relationship between these two things, we're going to be describing it as this is a relationship. So what we're going to say here is that a rectangle is a shape. Okay. Whenever we're specifying these arrows, this notation right here, always remember that it's going in the direction of the, essentially of the statement itself. So we're saying that a rectangle is a shape. Okay. And so the idea here is that because a rectangle is a shape, we would say that a rectangle is a type of shape. We can represent it with this inheritance relationship. So essentially what's going to happen now is that when we introduce some code into shape, we want to set this up in such a way that rectangle can inherit the fields and methods of shape. So to get started on talking about the benefits of this, one of the first ones is that we can inherit the fields and methods. Okay. And so what this means is that much like in the real world, where we might have a child that will inherit the characteristics and the behaviors of their parents, in Java or in programming in general, we can talk about these child classes, say like rectangle, and how they inherit the fields and methods, so sort of like the characteristics and the behaviors of their parent class, in this case shape. Another way that we could describe this relationship, in addition to saying that rectangle is the child and shape is the parent, we can also say that rectangle is the subclass and shape is the superclass. Okay. So we'll go ahead and start writing a little bit of code so we can set up at least enough to see this particular portion. So we'll go ahead and come over here, and I've gone ahead and at least created or kind of set up the first one of these files. We're just going to be reusing the majority of the code for our rectangle. So if you want to go ahead and just grab the rectangle class from one of the previous projects that we worked on, you can just go ahead and copy and paste the code from that into this. We're just going to go ahead and use that here. So what we've got set up right now is just our rectangle with our two private fields, length and width, set of public methods, make sure that we adhere to proper data hiding. We've got our constructor, which takes a length and a width. Let's go ahead and assign those to the fields. This will be the only constructor that I focus on for this particular example. We've also got our setters, so set length and set width, to be able to set the values for either of these two fields, as well as get length and get width, to be able to get the values for either of these two fields. Okay, So far, I've just got this code that I've brought over. In addition to this, we also need to go ahead and make a shape class, and then we need to establish the relationship between rectangle and shape. So we'll go ahead and create another file for this. We'll go ahead and call this our shape.java. And so inside of this one, I'm going to say public class shape. We'll go ahead and create a single field for this one. What I'm going to go ahead and do for the shape, since this is going to be the parent class of rectangle, I want this to be something that is a bit more general than what a rectangle is. So naturally a rectangle can take a length and a width, as we've already seen for the fields, but for the shape, I want to take into consideration the idea that this could be any kind of shape. So I'm going to give this something a bit more generic here. So I'm going to say private double apothem. Okay, so I'm going to be using this apothem field essentially as a particular dimension for effectively any kind of shape. In a very naive way of explaining it, an apothem is effectively going to be roughly half the height of the shape, or the polygon. In the case of rectangles, it's pretty much always the case that it's half the height. Okay. In addition to this, I'm going to go ahead and create a getter and a setter for this apothem. So we'll have our public void set apothem. We will pass in a value, so pass in one of these. And then right here, we'll go ahead and say this dot apothem is equal to apothem. And then we'll say public double get apothem. And we want to go ahead and return the value of that apothem field. Okay, so this is everything that I want as far as the shape class goes. The last thing I need to go ahead and do is also establish a relationship between the two of these. So right now I've effectively got all the code for this box representing my shape class and everything for my rectangle box representing that class. Now I need to go ahead and establish the connection, this arrow between the two of them that indicates this relationship. And so what I need to go ahead and do is come back over to my rectangle, and if you've been following this set of lectures or the set of videos so far based on the course itself, then you have probably already seen several programs where we deal with JavaFX applications. And for every one of those programs, whenever you make your own custom JavaFX application, you always had to include this line extends application, and essentially that's what we're going to do here. And what was going on there is we were inheriting certain things from the application class. That's where, as I had mentioned in one of those previous videos, where the launch and the start methods come from, is from that application class. So that's based on the idea of inheritance, where you are inheriting those two methods from that class, and you're not able to use them in your own class, even though you didn't explicitly define them yourself. So we can go ahead and do the same thing here. We're going to use that extends keyword, and then we're going to specify the name of the class that rectangle extends, or essentially what rectangle is now going to become the subclass or child class of. Okay. Once we've got all this set up, we'll go ahead and create a third file. And with this third file, we're going to go ahead and make a rectangle demo. And this is where we're going to include the main method so that we can actually start testing out these two classes that we've created. So we'll have our public class rectangle demo. So we'll have our main method, so we'll have our public static void main, our string array of arguments. And inside of here, I'm just going to go ahead and make an object of the rectangle class. So we'll have our rectangle rect equals a new rectangle. And for this one, the dimensions, I'll go ahead and give this something like 15.5 for the length, and let's say something like 7.8 for the width. Okay. And then the next thing I want to go ahead and do is just have two print statements to go ahead and print off these two values. So I'll have system.out.println, and we'll say the length of the rectangle is plus rect.getLength. And then we'll have a second print statement, system.out.println, and we'll say the width of the rectangle is plus rect.getWidth. Okay, so we'll just go ahead and print out both of those values. So we'll come over here and we'll compile this. So to compile this, we want to go ahead and grab each one of those different those different files. So we're going to need our shape.java, we need our rectangle, and we need a rectangle demo. So go ahead and compile that. And then we'll go ahead and run the rectangle demo, since that has our main method inside of it. And we can see the length of the rectangle is 15.5, and the width of the rectangle is 7.8. Okay. In addition to these two, I want to go ahead and include a third statement here. And for this one, I'm going to say system.out.println, and I want to say the apothem of the rectangle is plus rect.get apothem. Okay. So at this point now what I'm going to do is I'm going to call a method that is not in the rectangle class itself, but is instead a part of the shape class, this getApothem method. And what this is going to do is, because rectangle extends shape, it inherits the fields and methods from shape. That means I can use any of these methods on objects of that rectangle class. So I can go ahead and do rect.getApothem right here, and getApothem is a method that is being inherited by the rectangle class from the shape class. So if I go ahead and save this, we'll come over here, we'll compile it, and we'll run it, and we can see now the apothem of the rectangle is, and it's 0.0 right now, which makes sense because of the fact that we set it to 0.0 here, but we never changed it or modified it in any way. So what we could go ahead and do is, maybe before we get that apothem, we'll include an additional line right here, and we'll go ahead and set the apothem to some value. So let's say that our rect, do rect.setApothem, and let's say that we want to go ahead and adhere to what I mentioned before, which is that the apothem tends to be the height divided by 2, so it's half the height. So we want to go ahead and do that here. So let's say that maybe the width can represent our height. So we'll say rect.getWidth, and we'll just go ahead and divide that by 2. Okay, so that's going to be the value of our apothem right there. Essentially that'll be something like 3.9. So we want to go ahead and set it to 3.9 here. So go ahead and compile that. And then we'll run our demo. And then we can see the apothem of the rectangle is 3.9, which would be half of that 7.8 that we have right there. Okay. So this is showing us the ability to inherit these two methods from that class. Okay. The other thing that we can go ahead and talk about, there's a second benefit for inheritance, which is this idea of specialization. And this is achieved through what is known as overriding. Okay. So this is going to be the second thing that we talk about now. So you might have already kind of gotten a general idea about this based on this relationship. Rectangle is a shape, but a sort of broader description of the relationship between the parent class and the child class is that the parent class should always be something that is more general than whatever the child class is. So the idea is that the shape class here is more general, while the rectangle class is more specialized. And so in order to demonstrate this specialization, what we can go ahead and do is introduce a couple of different types of methods. And specifically what I want to do is show the ability to override a method from the parent class inside of the child class. So to do that, I'm going to come over here. I'm then going to go ahead and create a method here. I'm going to call it GetArea. So we're going to do public double GetArea. And for the functionality of this GetArea method, what I want this to do is just have a sort of general, but not necessarily correct calculation to get the area of just any shape or polygon. So I'm going to do return. We'll do 1/2 or 0.5 times this apothem squared. So we'll do this dot apothem times this dot apothem in order to square it. So just multiply it by itself. We'll then come over to the rectangle class. And inside of here, I'm going to go ahead and add a GetArea method as well. So we're going to do public double GetArea. And this is going to return the calculation of the area of a rectangle. So do length times width for this one. go ahead and return that. Okay. So the purpose here is that we want a more specific or more specialized version of GetArea that's going to calculate the area for a rectangle by doing length times width, versus this more general version of GetArea that's calculating it based on the apothem for just any shape. Okay. So then coming over to our code, we'll go ahead and add another print statement right here. And for this print statement, I just want to go ahead and say the area of the rectangle is, plus we'll go ahead and do rect.getArea. Okay. So the idea here is that we want to see if this is going to give us the area based on the length times the width, or the area based on 1/2 of the apothem squared. And the reason that I say we want to check to see what's going on there is because of the fact that if you notice right here, for both the shape and the rectangle class, they both have a method called GetArea, and the parameters for those methods are the same in the case that neither of them has any parameters. So that tells us that the method signature for this GetArea method in both rectangle and shape is exactly the same. So given that, and because of the fact that rectangle extends shape, so that means that it's going to be inheriting the fields and methods from shape, the question then is, which one of these two GetArea methods is this rect object going to end up calling and using? So we're going to come over here, and we're going to go ahead and compile those 3 files. We'll go ahead and run this, and seeing right here, we've got the area of the rectangle is, and we've got a little bit less than 121. And so if we think about the 2 different ways we could get this, we have 15.5 times 7.8 versus 1/2 of a little bit less than 4 squared. Well, a little bit less than 4 squared times 1/2 would give you, just under 8. 121 looks to be much closer to 15.5 times 7.8. So this indicates to us that the length times the width, that particular version of our GetArea method, is what was used there. And the reason for that is because of the fact that since we created a rectangle object specifically, if we look for a particular GetArea that we're going to be using, it's going to go with whichever one is closest to the object that we have. In this case, what that means is that because we made a rectangle object, if we look in the rectangle's definition, or in that class, we see GetArea right here, so we're just going to use this. So one of the things that we can make a note about right here is that this is an example of overriding a method. So I'm going to add an annotation that we can include whenever we override a method, which is this @override. Okay. So this is what we use to specify that this version of GetArea is going to override this version of GetArea. So now anytime we create an object for the rectangle class, we're doing length times width instead of doing 1/2 of the apothem squared. And then to demonstrate that if we went ahead and made an object of the shape class, so we'll go ahead and do that. So we'll have a shape, we'll just call it shape with a lowercase s, say this is equal to a new shape. Don't specify any parameters here since we're calling the default constructor, since we do not yet have an explicit constructor for our shape. And then right here, let's go ahead and set the apothem to some value, and then also go ahead and get the area of this shape that we made. So do shape.setApothem. We want to make sure that we set it to something even, and then we'll go ahead and just print this out. So say system.out.println. We'll do the area of the shape is plus our shape.getArea. Okay, so go ahead and save everything like this, and then come back over here. We'll compile this, and we'll run it, and we can see right here we get the area of the shape is 18. And so if we double check, we've got 6 squared, that gives us 36, and then we'll do 36 divided by 2, or multiplied by 0.5, and that gives us that 18 that we have. Okay, so this shows us that if we create an object of the shape class, we're just going to use this version of GetArea, but if we create an object of the rectangle class, we will instead use this GetArea. Okay, so this is an example of specialization through overriding. And then one of the last things I want to go ahead and mention regarding this is to make sure that we understand the distinction between the idea of method overloading and the idea of method overriding. So we've seen both of these between maybe the last couple of videos related to Chapter 8, and now seeing this here for these videos related to Chapter 10. So whenever we create two methods that have the same method signature, meaning they have the same name and the same data types for their parameters, but one of these methods is located in the child class and the other is located in the parent class, this is an example of method overriding. If instead we have two methods that have the same name but their parameters are different, that's going to be an example of method overloading. And it's important to keep in mind that method overloading could occur whether that's with two methods that are in two separate classes, or if it's with one method being in the child class and one being in the parent class. So to give you an example of that, let's say add another parameter to this. So I'm going to add a parameter for getting the perimeter. Okay. And right here I'm going to go ahead and delete this, or remove one of these apothms and replace it with the perimeter. Go ahead and remove that as well, since this is going to come from this parameter and not a field. So we'll go ahead and save that. And if I do that, I'm going to go ahead and remove this annotation because this is no longer true, because now the GetArea that I have right here, its method signature does not match the method signature of this one. So this is no longer an example of method overriding. This is now an example of method overloading. So if I do this, and then I come over here, the overall output for this is going to be pretty much the same. The one difference is that now I need to pass in a parameter for my GetArea. Let's say I use 10. So we're going to do 10 times 6 divided by 2. So instead now the area for this shape is going to be 30. So if we come over here, compile this, and we run it, we can still see pretty much the same outputs. The only real difference now is just the sort of distinction internally, which is that by doing this, now we're going to go ahead and overload the methods instead of override them. Okay. So keep in mind those couple of different distinctions. Method overriding will only occur whenever we have two methods with the same signatures in two different classes, a subclass and a superclass. And then with method overloading, that's whenever you have two methods with the same name but different signatures, and it doesn't necessarily matter if both of those methods are in the same class, or if both of those methods are in two separate classes with some kind of relationship, like a subclass and a superclass. Okay, so that'll wrap up everything with that. The last thing that I want to go ahead and address as well is going to be dealing with the UML class diagram for these. So essentially this marker that I've indicated right here is already a pretty good example of exactly what I'm talking about. So we've got our rectangle. I went ahead and simplified this before, so if you wanted to, you could include the fields and methods for this rectangle class. And with the shape, same thing. I've simplified it to only include the name. You can also include the fields and methods. The key thing that we're adding here that is unique to this UML class diagram that's showing inheritance is this little arrow that I've included that points towards my shape. So this is the notation in UML to indicate that one class inherits from another class. So you're going to use an arrow with this open arrowhead, meaning that we leave the inside of it empty. Okay, so that covers that. Okay, the last thing I want to go ahead and kind of start to see an example of in this is that I want to also add one additional method to my shape that I have conveniently left out, which is the constructor for it. So I want to be able to add a constructor, say like public shape. Maybe this will do something kind of similar to our set apothem method, just at object construction. So we'll go ahead and do double apothem. And right here, we're just going to say this dot apothem equals apothem. So we'll go ahead and do that. And now that I've added this, I can come over here, and right here I want to go ahead and add something so that I can create an apothem, so that maybe I don't have to set it right here anymore. So I'll go ahead and remove that and replace it here. So now whenever I first make my shape object, I want to go ahead and set the apothem to 6, and then right here We can actually just completely remove that line. And so then when I get the area at the very end, we can just do this 6 times 10 divided by 2, still get our 30. Okay, so I want to go ahead and compile this, and at that point try to run it and see how that works. So I've tried to compile this, but it seems that we've run into a little bit of an error with this. So our constructor shape and our class shape cannot be applied to the given types. So we see just a curly brace right here. And then right here we're saying that we required a double, but we found no arguments. So somewhere in this we are trying to use the constructor for shape, but that constructor didn't have any arguments passed into it, meaning right here no arguments were found. And it was expecting a double because if we look at our shape constructor, we can see right here it's expecting a double as an argument. So somewhere in our code we've managed to call this shape constructor, but we didn't pass any arguments into it. So to kind of dispel the mystery here, it's actually right here. Whenever I call my rectangle constructor, this actually ends up calling the shape constructor as well. So moving into the next video, I want to go into a little bit more detail about exactly how the constructors work whenever you're dealing with inheritance.